Still on partial fractions, but this time around we'll talk about fractions with repeated linear factors at the denominator. In the previous video, we talked about fractions with non-repeated linear factors at the denominator. So here I'll teach you how to resolve a fraction that has a repeated factor at the denominator. Now let's consider these cases. For example, how do I resolve this into its component partial fractions? Now, you can see that x plus 7 is to the power of 3. That means x plus 7 is repeated 3 times. It means that the partial fraction is equal to a x plus 7 plus b all over x plus 7 squared plus c all over x plus 7 to the power of 3. This is it. How do I resolve this? At the denominator, I have x squared and x plus 3 squared. So the resolution will now be a all over x plus b all over what? X squared, okay, plus c all over x plus 3 plus d all over x plus 3 squared. I hope you get what I'm doing. This is it for this very case. Alright. Similar to that is what we have in number 3. At the denominator, we have x plus 1 squared, x minus 3 squared. So the resolution will be a all over x plus 1 plus b all over x plus 1 all squared. You get it? I've taken x plus 1. I will now take x plus 1 squared. Okay? Plus c now all over x minus 3. Then I will now take x minus 3 squared. Good. So this is how we resolve a compound fraction with repeated linear factors at the denominator into its component partial fractions. Now let's dive into the first example that we have. I want to resolve 5x plus 2 all divided by x plus 7 squared into partial fractions. So based on what I showed you just now concerning resolution of fractions involving repeated linear factors at the denominator, this partial fraction is equal to a all over x plus 7 plus b all over what? X plus 7 squared. Good. Alright, let's take LCM. The LCM of these two is x plus 7 all squared. Yes, x plus 7 is a factor of this. So the LCM is x plus 7 all squared. X plus 7 all squared divided by x plus 7, we have x plus 7 left. That's what I'm saying. X plus 7 all squared, which is the same thing as saying x plus 7 times x plus 7 divided by this x plus 7. It will cancel 1, leaving us with just x plus 7. Okay? So this divided by this is x plus 7 times a is a bracket s plus 7. This again divided by this. Of course, they are the same. S plus 7 squared divided by s plus 7 squared is 1. 1 times b is just b. So what I'm working with, these two fractions, is what I'm working with. That is 5x plus 2 all over s plus 7 all squared is equal to a bracket s plus 7 plus what? B all divided by s plus 7 all squared. The denominators are the same. They will cancel out, leaving us with 5x plus 2 equal to a bracket s plus 7 plus what? B. Now, see how we are going to get the values of a and b. Using the cover-up method, we can eliminate a. If we choose a value for x minus 7, minus 7 plus 7 is 0. Everything here turns to 0. When x equal to minus 7, we are trying to eliminate a now. If I put minus 7 here, that will be 5 times minus 7, which is minus 35 plus 2 is equal to a bracket minus 7 plus 7 plus what? B. Minus 35 plus 2 is minus 33. Everything here is 0. To cancel that. And B is equal to what? Minus 33. Alright? What now is the value of A? Okay, see what we are going to do to get A. From this same equation, let's expand it. Just watch. Let's expand it. We have 5x plus 2 is equal to A times x is ax. A times 7 is what? 7a. Then plus b. We will now do what we call comparing coefficients. Comparing coefficient. Watch this. I have a term in x at the left hand side. I also have a term in x at the right hand side. Their coefficients are the same. That is what it means. Okay? So 5 here is the coefficient of x here. A here is the coefficient of x here. I can say that 5 is equal to a, which means a is equal to 5. So comparing coefficient, 5 is equal to what? A. Now, let me go further, okay, to show you something. We just compared the coefficient of x. Now, let's compare the constant. 2 here is a constant, right? Okay. Do I have constant at the right-hand side? Yes. 7a and b, they are constant. So, comparing coefficient also, I can say 2 is equal to 7a plus what? B. 7a is a constant. B is also a constant. 2 itself is a constant. So constant at the left is equal to constants at the right. That's the point. We are also comparing coefficient here. Now, do we know what the value of b is? Minus 33. So we can put it here. 2 is equal to 7a minus 33. Right? We are looking for a, don't forget. So if I collect like terms, 2 plus 33 is equal to 7a. This is 35 equal to 7a. If I divide both sides by 7, what will be a? A is equal to 5. So I got 5 here, I got 5 here. That's to show that a is equal to 5. B is what? Minus 33. Okay, so this is how we do comparing coefficients. So it means that 5x plus 2 all over x plus 7 all squared is equal to, what's a? 5 all over x plus 7. What's b? Minus 33. Minus 33 all over what? X plus 7 all squared. X plus 7 all squared. So this is the partial fraction resolution of this very compound fraction. Alright? Let's resolve this into partial fractions. X squared plus 3x plus 1 divided by x squared times x plus 3 all squared. Here we have two factors that are repeated. X repeated twice, x plus 3 repeated twice also. So the decomposition is equal to a all over x plus b all over x squared, remember what we did earlier, plus c all over x plus 3 plus d all over x plus 3 all squared. Let's take LCM. The LCM of the denominators is this, actually, yes. So it is x squared bracket s plus 3 squared. S squared bracket s plus 3 squared divided by x is what? Check it out. S will cancel one of the x. What's left? X times s plus 3 squared. So this divided by x is x bracket x plus 3 squared times a. That will be a s bracket s plus 3 squared. Okay. This again divided by x squared is s plus 3 squared. The s squared will cancel this. So we have x plus 3 squared times b. That is b, s plus 3 squared. Okay. X squared bracket s plus 3 squared divided by x plus 3. We have x squared times s plus 3. This s plus 3 will cancel one of the s plus 3 here because this is s plus 3 squared. So we'll be having just x squared bracket s plus 3 times c. That will be cx squared bracket s plus 3. And then x squared bracket s plus 3 squared divided by this s plus 3 squared. We'll be having just x squared left times d. That will be ds squared. Okay, so at the left hand side we have s squared plus 3s plus 1 all over s squared bracket s plus 3 all squared. The denominators are the same, they will cancel out. We now have s squared plus 3s plus 1 is equal to ax bracket s plus 3 squared plus b bracket s plus 3 squared plus cs squared bracket s plus 3 plus ds squared. I can plug 0 for x into this equation. If x is 0, everything here will disappear because 0 times everything is 0. If x is 0, everything here will also go. Of course, this will also go. So when x is equal to 0, I have 0 squared, which is 0, plus 3 times 0, 0, plus 1 is equal to 0 plus, this is b, in bracket, 0 plus 3 is 3, that's 3 squared, plus, this is 0, this is 0, so 0, 0. Everything here is 1, and this is what? 9b, because 3 squared is 9. So, dividing both sides by 9, b is equal to 1 all over 9. I've gotten b already. Let's get d. What value of x are we going to plug in to make all other expressions disappear except d? If we plug in minus 3 for x, minus 3 plus 3 is 0. This will go. Minus 3 plus 3 is also 0. Minus 3 plus 3 is 0. That is to say, these first three expressions will leave. So when x equal to minus 3, we have minus 3 squared plus 3 times minus 3 plus 1 is equal to 0, 0, 0. What we have here says d times minus 3 squared. Good. Minus 3 squared is 9. So we have 9. 3 times minus 3 is minus 9 plus 1 is equal to minus 3 squared is 9 times d, 9d. Alright? 9 minus 9 is 0. 0 plus 1 is 1. 1 is equal to 9d. 9d. Good. 9 minus 9 is 0. 0 plus 1 is 1, which is equal to 9d. So if we divide both sides by 9, 9 cancels 9. That means our D is equal to what? 1 over 9. That's what it means. So we have gotten B and D. So what we have to look for now is A and C. Just watch what I'm going to do very carefully. I want to expand everything here. I want to expand it. Okay? So at this side I have x squared plus 3x plus 1. Which is equal to, if I expand s plus 3 squared, I will obtain this. S squared plus 6s plus 9. If I expand s plus 3 squared, the same thing. So it will be b times s squared plus 6s plus 9. If I expand this, that will be cx squared times x. That's cs cubed. Cs cubed. Cx squared times 3. That will be 3cs squared plus dx squared. Okay? Ax times s squared, as cubed. Ax times 6s, 6ax squared. Ax times 9, 9ax. B times x squared, bx squared. B times 6s, 6bx. B times 9 is 9b. And all others will follow. I'm expanding because I will have to compare coefficients to get A and C. Now, I am having terms in s cube here, as cube and cs cube. But at the right hand side, there is no expression in x cubed. So we will take that to be 0, since there is no expression in s cube. What I'm doing now is comparing coefficients, okay? There are terms in s cube, as cube, and cs cube. Their coefficients are a and c. A plus c. This is equation 1. Now, there are terms in x squared here. 6ax squared, bx squared, 3cx squared, dx squared. Here I have x squared. The coefficient is 1. So 1 is equal to, what are the coefficients of x squared here? We have 6a plus b plus 3c plus d. Those are the coefficients of the terms in x squared. Good. So I have two equations already. Equation 1, equation 2. But the values of b and d are known. 1 over 9, 1 over 9. That's what we got for b and d. So from this equation 2 now, we can just say 1 is equal to 6a plus 1 over 9 plus 3c plus 1 over 9. Alright? Let's go ahead here. 1 is shortcut. 1 over 9 plus 1 over 9 is 2 over 9. Alright? So if 2 over 9 crosses, it becomes minus. Minus 2 all over 9 is equal to, what's left now? 6a plus 3c. You must be very careful while doing this so that you don't make mistakes in the expansion and in the comparing of coefficients. Alright? Let's go ahead. 9 times 1 is 9, minus 2 is 7. 7 all over 9 is equal to 6a plus 3c. So this is our equation 3. Let me place it here. 7 over 9 is equal to 6a plus 3c, equation 3. So I can easily work with equation 1 and equation 3 now because they have a and c. I'm working with these two equations now. It's a simultaneous equation. Now, to eliminate a, for example, I will have to multiply this equation 1 by 6 because 6 is the coefficient of a here. So multiply this one by 6. And so we have 6 times 0, 0. 6 times a, 6a. 6 times c, 6c. Let's say equation 4. So it's easy now if we just say equation 3 minus equation 4. Alright? 7 over 9 minus 0. 7 over 9. 6a minus 6a is out. 3c minus 6c is minus 3c. So what do we do now to get the value of c? Divide both sides by minus 3. Or we can just say multiply both sides by minus 1 over 3. It's the same thing. Either I divide both sides or I multiply both sides by the reciprocal. 3 cancel 3, minus minus is a plus. So we have now c is equal to minus 1 times 7 is minus 7. 3 times 9 is what? 27. So the value of c is actually minus 7 all over 27. Let's get the value of a now. So in place of c now, I can write minus 7 over 27 into this equation 4. So we have 0 is equal to 6a plus 6 times minus 7 all over 27. Okay, 0 is equal to 6a minus 6 times 7 is 42. So collecting like terms, this will cross and turn to 42 over 27 is equal to 6a. So we can now divide both sides by 6, or better still, multiply both sides by 1 over 6. 6 will cancel 6. 6 here is 1. 6 here is 7. Okay, so it means that 1 times 7 is 7. 1 times 27 is 27. And that's the value of a. 7 all over 27. Let's now plug in these values for a, b, c, and d respectively into this equation. A is what? 7 over 27. So this becomes 7 all over 27x. B is what? 1 over 9. That will be plus 1 over 9x squared. C is what? Minus 7 over 27. That will be minus 7 all over 27 times x plus 3. And what's D? 1 over 9 plus 1 all over 9 bracket s plus 3 all squared. We have resolved this very compound fraction into its components partial fractions. I hope you enjoyed the video. Remember to subscribe, like, and share the video to your friends and to your classmates. I'll see you in the next one. Keep watching.